Hello everyone, my name is Peter Dimitrov from the OTP team, Stockholm, Sweden, and this is the OTP team update for CodeBeam San Francisco 2020. I have a short agenda for this presentation. I will talk about our planned releases, the highlights of our next major release, OTP 23, and also our long-term plans. We will have 3 release candidates. RC1 is already out, and then we already got valuable feedback from the community. 2 more release candidates will follow, and our major release is scheduled on 13th of May 2020. After that, we have 3 planned patch packages, 1 every quarter, containing bug fixes. Now let's talk about the features in OTP 23. Distributed spawn. We have improved the scalability and performance of the spawn operation. We also added new features such as distributed spawn monitor BIF. This function creates a new process and sets up a monitor automatically. Spawn opt BIF will support the monitor option for setting up a monitor atomically while creating a process. We've also added new spawn request BIFs for asynchronous spawning of processes. Spawn request supports all options that spawn opt already supports. Here comes 2 examples for spawn monitor and spawn request. As you see, spawn monitor returns a 2-tuple with a PID and a monitor reference. In the second example, we spawn a process asynchronously. When the spawn operation succeeds, the caller will be sent a message in the form of a 4-tuple, reply tag, request ID, OK, and PID, where PID is the process identifier of the newly created process. At decentralized counters. We have improved scalability of concurrent calls that change the size of a table, like @insert and @delete. This is for all table types. The improved scalability may come at a cost of longer latency of function calls such as @info. A new table option, decentralized counters, has therefore been added. It is default true for orders set with write concurrency enabled and false for all other table types. This option has no effect if the write concurrency option is set to false. There are new RT1 functions with UTF-8 default encoding, and these are atom to binary, binary to atom, binary to existing atom. Matching syntax improvements. In binary matching, the size of the segment to be matched is now allowed to be a guard expression, as in example 1. In the current map matching syntax, the key in a map pattern must be a single value or a literal. This leads to unnatural code if the keys in a map are complex terms. In OTP 23, the keys in map matching can now be guard expressions, as you see in example 2. The only limitation is that all variables used in the key expression must be previously bound. OTP 23 will support numeric literals with underscore, and just 2 examples. Distributed name process groups. A new implementation of the distributed name process groups has been added in the PG module. Thanks to Maxim Fedorov for the contribution. It is important to note that the PG module has only the name in common with the experimental PG module that was present in standard lib up until OTP 17. The PG module or process groups implement strong eventual consistency that is unlike PG2 that provides strong ordering guarantees. In process groups, membership view may temporarily diverge. Process groups can be organized into multiple scopes. The scopes are completely independent of each other. A process may join any number of groups in any number of scopes. Scopes are designed to decouple the single mesh into a set of overlay networks, reducing the amount of traffic required to propagate group membership information. New ERPC module. The ERPC module implements an enhanced subset of the operations provided by the RPC module, enhanced in a sense that it makes it possible to distinguish between return value raised exceptions and other errors. ERPC has better performance and scalability than the original RPC implementation. This is by utilizing the newly introduced spawn request BIF. Help in the shell. We have implemented EP48. EP48 proposes an official API documentation storage to be used by Beam languages. By standardizing how API documentation is stored, it will be possible to write tools that works across languages. We've extended the ordinary doc build with the generation of chunk files for all OTP modules. Built on these features, we've added online help in the shell. We've also added a new module, shell docs, with functions for rendering documentation for the shell. This can be used, for instance, by language server protocol implementation. The code module also got a new function, getDoc, which returns the doc chunk without loading the module. And here's some example, calling the help function on a list sort with the RT2. Container-friendly features. We have improved the handshake during connection setup in the Erlang distribution protocol. It is now possible to agree on protocol version without depending on EPMD or other prior knowledge of the peer node version. CPU quotas are now taken into account when deciding the default number of online schedulers, thus improving performance in container environments where quotas are applied, such as Docker with the CPU's flag. Erlang got a new option called address that can be used to connect directly to a node without being dependent on EPMD to resolve the node name, and more features will follow. Build with WSL on Windows. We have improved our Windows builds by using the Windows subsystem for Linux for building our Windows binaries. This change will make it easier to maintain our build scripts since they are the same for all other Unix-based platforms. SSH, SSL, and crypto. We implemented TCP/IP port forwarding in the SSH application that corresponds to the uppercase L and uppercase R options in OpenSSH client. The SSL application got new features like TLS 1.3 client that is available from 22.1. It now supports session tickets, both stateful and stateless, available from 22.3, and also got a new key update mechanism, also available from 22.3. TLS 1.3 is configured by default from OTP 23. We also removed SSL v3 support with this release. And crypto. In crypto application, a new crypto API is introduced. The main reason for a new API was that OpenSSL CryptoLib has changed its API several times. There are parts of the crypto app that are using very old APIs, while other parts using the latest one. It turned out that using the old API in the new way and still keeping it backward compatible was not possible. Therefore, the old API is kept for now, but it is implemented with new primitives. The old API is deprecated in OTP 23 and will be removed in OTP 24. And some words about our long-term vision. We would like to take active roles in the EEF working groups, documentation, build tools, interoperability, security. We also continue developing features that makes Erlang OTP more cloud and container friendly. We will replace the inet driver by using new socket NIFs. We are planning to implement Gen UDP and Gen SCTP API based on the socket NIFs. We also promote features that helps IDE integration, and we are currently investigating the quick TLS and quick protocols. And that was all that I wanted to present. Thank you very much for your attention.